Okay, today we're going to talk about inverse operations and properties. This is the beginning of our unit for solving linear equations in one variable. So we're starting unit 2, inverse operations and properties, and this is going to be on page 23 and 24 at least, maybe 25 in your book. So I'm kind of just put a little dash there and we'll fill that in after we figure out how many pages we need to use. So inverse operations and properties. In your Math Interactive notebook, you're getting a new digital Math Interactive notebook today that will be sent out to you, and you will be doing GP1 in the interactive notebook, updating it, and we're going to also give you a digital scavenger hunt on distributive property, and that will be in your Google Classroom. So let's go ahead and get started. So inverse operations. So of course we need to know what inverse means, right? So inverse means opposite. Or in a sense, how to undo your not, right? So if you have addition, the way you can balance that out is you do subtraction, and we'd be able to create the number 0. If you have multiplication, we're going to be able to do division to come up with the multiplicative identity of 1, and so forth. So addition. We also consider this to be positive numbers. And we say its opposite is subtraction or negative numbers. And we say that because we're going to start looking at everything through the addition lens. And we need to know that subtraction is the same thing as adding a negative. So when we were looking at a number, we need to be conscious of its sign. And its opposite in sign is going to be what its additive inverse is going to equal. So positive 2, its opposite is negative 2. And together those make the addition identity of 0. Okay. Multiplication. And its inverse is division. Also the multiplicative. And the reason why we say that is, like we've said above, we're going to start looking at everything through the lens of multiplication. Instead of dividing by 2, it's the same thing as multiplying by 1/2. And how do we undo that? We use the inverse, the multiplicative inverse, what I like to call the refliprical. To do that, because we're going to find out that the multiplicative inverse, when a number and its inverse are multiplied, we get the multiplication identity of 1. We're going to find that out when we're doing our properties. And lastly, exponents. And recently we found out that radicals or roots are its inverse. Now we've gone over, several secret things in math, right, that we need to know. That when we don't see an exponent on a term, we know that its exponent is 1. When there's no number in front of a variable, we know that the coefficient is 1. And things like that. There's things that we need to make sure that we can recognize in math. Number 1, we need to recognize positive numbers. So here I have x plus 3. I can see the positive in front of the 3 in a sense because of that addition, but I need to recognize that x in itself is a positive number right now. So 3 plus x, all because you don't see a sign in front of a number. When you don't see a sign in front of a number, it's assumed to be positive. Second thing we need to recognize is a term with a negative in front of it. So x, what we used to say minus 2, is the same thing as x added to negative 2. So subtraction is the same thing as adding a negative number. Also, with that in mind, if I want to rewrite this, I would need to take that sign with it, that negative sign. So this is equal to negative 2 plus x, not 2 minus x. Right? So we have to make sure we're keeping the signs with their terms. The third thing I need to recognize are coefficients are always in front of a variable. If I don't see one, it is assumed to be 1. Now, one thing that's different when we say that, we mentioned earlier that with exponents, if we don't see an exponent on the base, we assume it to be 1. And each part of a term is its own base and has its own exponent. But for a term can only have one coefficient. So if I have 3x, 3 is my coefficient. If I have 3xy, 3 is the coefficient of xy. It's not 3x, 1y, because this is all together, because it's being multiplied. Versus exponent-wise, this would be a 1, this would be a 1, and this would be a 1. So we need to be able to distinguish between a term and a base. And that kind of brings us to our fourth thing that we need to recognize, and that is that terms are separated by addition or subtraction, versus bases are separated by multiplication, right? Or we're going to say division, but we really mean the multiplicative inverse, so like the fraction bar. The difference being there's only a term has only one coefficient, and that's in front. And within a term, each base has its own exponent. And so that's just kind of the beginning. Now we're going to move on and talk about the properties. So this is 24 in your notes. So we have inverse properties. The first one is the multiplicative property, or the multiplicative inverse property. And basically what this tells us is a multiplicative inverse for a number A is the number flipped over the fraction bar. Right? So 1 over A. And this is actually called the reciprocal. So when a number A is multiplied by its reciprocal, it yields is another word for equals, the multiplicative identity of 1. So A times 1 over A equals 1. Conversely, 1 over A times A, or A over 1, also equals 1. Okay, the additive inverse, or additive inverse, we'll say inverse on this one, inverse property. Remember, this is inverse 2, that's why we call them the inverse properties. The additive inverse, can't spell tonight, additive inverse of a number A is the number that, when added to A, yields the additive identity 0. So A plus negative A equals 0. Conversely, negative A plus A equals 0. And of course, the reason why we call this the multiplicative identity and the additive identity is because if you add 0 to anything, it's not going to affect anything. It's not going to change anything. Just like if we multiply something by 1, it doesn't change anything. Okay, those are the two inverse properties. Okay. Then we have the golden rule of algebra. This is kind of like the golden rule in life. Golden rule of algebra. Do unto one side as you do onto the other side. And that just means is if we're going to maintain equality or inequality, we have to do the same thing to both sides in order to maintain that balance. How do we do that? Well, we have the addition. There's also the subtraction properties of equality. But again, our focus is going to be on the addition property of equality because we're going to start looking at everything through the lens of addition. And this tells us if we add the same number to both sides of an equation, right, or the equal sign, essentially, the sides remain equal. So A plus B equals C. If I add E to both sides, I still remain equal. Then we have the multiplication, division property of equality. So if we multiply the same number to both sides of the equation, the sides remain equal. So A equals B. If I divide, or say multiply both sides by 1 over C, that's a little bit hard to see. Multiply both sides by 1 over C, you end up with A over C equals B over C. So we've maintained equality. And it looks like we're going to need one more page. So we're actually going to be going 23 through 25, the pages of our notebook. Okay, last property of equality is called the substitution property of equality. And that tells us if x equals y, then x or y can be substituted for each other, and the sides of the equation remain equal. So if we know that y equals x, or a equals b, whatever you want to call it, and we have x plus 3 equals 7, therefore y plus 3 must also equal 7. See, I exchanged the x and the y because they are equal to each other. And that holds true for like a single term or a whole expression. And we'll definitely be using that when we get to systems. Okay, so moving on. So distributive property. We're going to do some of these symbolically now, just to make our life easier. Except distributive property will. Distributive property, often called the distributive property of multiplication or division. So it doesn't apply to addition. And basically what it tells us, if I have A times the sum of B plus C, right, that multiplying A times B and A times C, and then adding those two together is the same thing if I added these two together and then multiplied it. And the reason why this comes so in handy is because when we're dealing with variables, we can't often add this together inside. So distributing, right? To me, when I think of distributing, I think of passing out papers, right? Or shaking hands with people you just met. You have to go to the party, you have to introduce yourself to each host. Then we also have what we call double distributive. Some people like to call it FOIL. And it's just us making this bigger. So what happens if we have A plus B times C plus D? Well, it means A has to meet everybody at the party and B has to meet everybody at the party. We call this first, outside, inside, last. So A times C plus A times D plus B plus C plus B plus D. First, so the first in each parenthesis, outside. Imagine if you have your hands outside, right? The outside from each parenthesis. Then the inside, because if you are not outside, you have to be inside. So the inside too. And the last terms in each parenthesis. Okay, a couple more. Reflexive. Hopefully, think reflexive, think reflection. This tells us that any real number is equal to itself. In other words, A equals A. Real deep. Okay, symmetric. I like to liken this to, you're going to make that pumpkin, you fold it over, you draw half the pumpkin or half the Christmas tree, right? And you cut it out, and then you have two equal sides. And when you're looking at them, doesn't matter which side you're looking at, they look exactly the same. So this property states that any real number or real numbers, A and B, if A equals B, then B equals A. In other words, we can flip the sides of an equation and still the same value. So if I have A plus 4 equals 7, then 7 must equal A plus 4. All I did is I took both sides of the equal sign and literally flipped them over. And that's what the symmetric property shows you. And last one, now you're tired of properties. Transitive. Transitive is kind of like here, there, and everywhere. The property states that for any real number, or real numbers, A, B, and C, if A equals B and B equals C, then A must also equal C. And that's what the transitive property tells us. So that's our start with all the properties that we're going to be used to justify our work when we're solving equations. Make sure you go back and complete your Math Interactive notebook, and you have GP1 to finish and your digital scavenger hunt.